High nitrogen oxide emissions have fundamentally brought into question the survival of diesel technology. But it doesn't have to be this way, because this prototype from Continental has got what it takes to recover the tarnished reputation of diesel engines.
The exhaust after treatment on diesel engines has gone on for a long time at the expense of the fuel consumption. That means lowering nitrogen oxides goes along with an increase in fuel consumption, respective CO2 emissions. We have solved this trade-off now. With the super clean electrified diesel car, in the test cycle, but also in real driving mode, the NOx emissions remain well below the 80 milligrams per kilometer target applicable 2020 onwards.
60% less nitrogen oxide. This pledge also refers to actual traffic conditions. To prove this claim, Continental engineers perform a real driving emissions test on inner-city and country roads and on freeways. The test system precisely measures and indicates at any point in time how much nitrogen oxide has been emitted so far.
I'm very confident about the results. With this car, we can reduce the NOx emission in the city and in the overall test cycle below 60 milligrams per kilometer.
This would be a huge breakthrough. But how does it work? Emission cleanup in Continental's new diesel system starts working shortly after the engine is started. This is important because pollutant emissions are highest during the first few kilometers.
Normally it takes minutes until the exhaust catalyst reaches its operating temperature. We found a way to heat it up much faster.
For this purpose, after the regular combustion process, an additional quantity of fuel is injected into the cylinder and ignited. The effect can be seen quickly.
We can already see that the NOx emissions have gone down significantly. So this shows us that the SCR catalyst is already working efficiently.
This effect is further enhanced by an electrically heatable catalytic converter, which is installed directly behind the engine. As well as its heating effect, it ensures that the urea solution required for emission after treatment can work optimally on the exhaust gas. After about an hour, average nitrogen oxide emissions have been significantly reduced as a result of these two measures.
At the moment we are driving on a value below 60 milligrams per kilometer. Generally speaking, flowing traffic reduces the emissions. If we have to stop and accelerate often, emissions go up.
This reduction in emissions, however, does not lead to increased fuel consumption. A 48-volt hybrid system, which Continental has successfully developed for several other cars, takes care of that. This mild hybrid with a small electric motor recovers energy during braking, supports the diesel engine when accelerating, and enables the vehicle to switch to the extremely economical coasting mode in certain situations.
While we are accelerating, diesel engines produce higher NOx emissions than normally. If the combustion engine is supported by an electrical engine, we can reduce fuel consumption and also emissions.
A country road 30 minutes later. The cleaning system has been working with amazing efficiency.
Here on the country roads, we are driving with a speed between 60 and 90 kilometers per hour. Because of this more constant driving style, we can further reduce our emissions compared to the city.
This trend continues on the freeway, even though here the vehicle is traveling at over 100 kilometers per hour for several minutes. After 93 kilometers and a test run of almost 2 hours, we have the proof. With this result, Continental's new diesel technology stays well below the limit for nitrogen oxide emissions set for 2020, and this has been achieved under real driving conditions.
The results meet my expectation. The super clean electrified diesel can significantly reduce the NOx emission. This means that the diesel engine is not only efficient, but also clean.
And at a reasonable price. The entire system, including the 48-volt unit, will cost less than 1,000 euros. All this helps save the reputation of diesel today, and it also paves the way for new and innovative solutions in the future.
42 milligrams is a great result. For us, This super clean electrified diesel is the first step. We are working at present on additional measures to further optimize the CO2 emissions and also the NOx emissions at the same time. One of those measures is the development and evaluations of synthetic fuels on diesel engines.